We're going to remember all the stuff we learned, right? Yeah. Okay, so look at number 5. Okay, first question. What is in the graph? Okay, it's a graph of, okay, focus, F. And then what is G? G is the integral of F starting where? At negative, and then going till X. So, if I want G of 0, I would be plugging 0 into X, so it'd be the integral from negative 3 to 0 of F of t dt. Okay, then I'm looking at a graph of F. I need the integral. I find the area. And what shape is it?
Triangle. Rhombus.
What?
Is it right?
A trapezoid. A rhombus is when it's like a square, but, you know. Okay, so 1/2. How long is this base?
4.
No height.
No, it's 3.
2. Look at the y value. Yeah. Remember, the bases are this way on the trapezoid. They have to be parallel.
Oh.
Okay, so 2, and then how long is this base? 2 plus 1, and then what's my height between them? 3. So I have 1/2, 2 plus 1 is 3, times another 3, that's 9/2 or 4.5. Okay, next part, I want G prime of 0. Then I want G double prime at 0. But here's the problem. I don't have an equation for G prime, but I can find it using G. So let's review. This is the most important step. Okay, G of X is the integral from negative 3 to X f of t dt. Then G prime would be the derivative of that. And this is what we learned yesterday, that when I take the derivative of an integral, what's the only thing that happens? The t changes to an x, but it's still regular f. So this would be f of x. Now, what if I wanted the derivative one more time? F prime of x. And if I'm looking at a graph of f, well then f is going to be the y value, and f prime is going to be the slope. Very good. So let's do it at 0. If I want G prime of 0, that's the same as f of 0. And if G prime is really f of 0, then it is 1. Good job. What about G double prime of 0? That'd be f prime of 0. Why is it DNE? That's correct. Because it's a, what? Cusp. Very good. Okay, because f has a cusp at x equals 0. You cannot take the slope at a cusp or a corner. Okay, let's do part B. Okay, I want G of negative 4. Well, G of negative 4 is plugging in negative 4 where my x goes. So it's at the top of the integral. And then if I have the graph of f, then I'm going to be doing the area. So from negative 3 to negative 4, I see this little shape. How do I find the area of that? Okay, 1/2, my base is 1, my height is 2. 1/2, 1 times 2, what's my area? Half and 2 cross out, so it's just a 1. It is backwards, and if it's backwards, what do we have to do? Negative, negative, good. Okay? So I'm going to write here, because those endpoints were backwards, I take my positive 1 area, and then I switch it to be negative. Okay, next I want G prime of negative 4, but that's really f of negative 4. Because remember, G prime and f are the same. So f of negative 4, what's the y value? 0, because negative 4 would be here. Good? Okay, then I want G double prime. What's G double prime the same as? F prime of negative 4, which is this slope. Okay, so then I look at this little line here. I need to count the rise over run. 2. Very good. My slope there would be 2 over 1. That's your slope. Good? It would not be negative because it's uphill. Okay? All right, next question. We want critical numbers. Remember, critical numbers happen when g prime equals 0, but what's g prime the same as? G prime is the same as f. So really, if I want g prime to change sign, I need f or the y values to change sign. There are 3 critical numbers on this graph. What are they? Negative 4, 1, and that's actually a 3, right? But yeah. Okay, now out of those numbers, which is a min, which is a max, which is a neither? Okay, that's a min. 1 is a neither. And that's a max. And we understand why. It's just because of the sign change. So if it goes minus to plus, that's a min. Plus to minus is a max, and then if it touches but doesn't change, that's a neither. So I would put x equals negative 4. That is a relative minimum. It is a relative minimum because g prime, which is really f of x, changes negative to positive. So it's very similar, hopefully, to what you already know how to do from semester 1. Okay, then for x equals 3, I would say it's a relative maximum. And it's a relative maximum because g prime of x, which is really f of x, changes from plus to minus. And then x equals 1, we said was a what? A neither. Because g prime, which is really f of x, doesn't change sign. And then remember, on the AP test, okay, they're not going to ask you all of the parts of these questions. This is just all of the different parts I've seen, and I put them on every graph. Okay, so they probably won't ask you to do all of the work that we're doing on every single one of these. Now, in part C, we're finding relative maximum, relative minimum. What is an absolute minimum? What's the difference? Candidates chart, very good. If it's absolute, there can only be one, and you have to do a candidates chart. Okay? So, in my candidates chart, what goes in it? Endpoints, so negative 5 and 4. And then critical numbers that aren't neithers. If it's a neither, I can skip it. Now, is there any other number out of these 3 besides 1, which is a neither, that I can skip? What do I want? Min. So which one's not going to be a minimum? 3 is a max. So if I needed the absolute min and the absolute max, I'd have to put both of them. But if they're telling me I only need the min, then I'm only going to put negative 4. Now, remember also that you don't want to do extra work, right? So look at your part A and your part B. Did I already find G at one of those? Which one did I already find? At negative 4, what did G come out to be? Negative 1. So I'm just going to steal that from part B because I don't want to redo it again if I already found negative 4, the y value is negative 1. Now, remember that we are plugging into g of x, which is the original function that had the integral in it. Okay, so first one I'm going to find is g of negative 5 to fill in my chart. G of negative 5 is the integral from negative 3 to negative 5. Okay, and then I'm coming back to this equation here that they gave me. Now, if I'm going from negative 3 to negative 5 on the graph, what is the area going to be? Cancels. Because negative 3 I shade backwards, then I shade backwards to negative 5. I end up with 2 triangles that are congruent, but one's positive, one's negative, cancels out, so the integral is 0. Okay, then we need to do the same thing at 4. So I want g of 4. It'd be the integral negative 3 to 4, f of t dt. We did the integral from -3 to 0, but we didn't go all the way to 4. So we're going to have to do a little bit more work, but we've already done some of it. Why is what? Because remember up here, -3 is the bottom of the integral. That's what they're telling me for g. It's always the integral starting at -3 until whatever the x is. Okay? So let's figure this out. We need the integral from -3 to 4. So come up to your graph. -3 starts here, and then I have to go all the way to 4, which is here. Okay, how big is this? We already found it. The yellow trapezoid. 4.5 or 9/2, either one is fine. Okay, then I have to keep shading. What is the next shape that I'm shading? Okay, something weird. We'll ignore it for a second. Okay, what's the next shape that I'm shading? Okay, 2 triangles, but what's going to happen? These 2 triangles are going to cancel out. So really, the only thing I need to figure out is this shape right here. So here's what I want you to do. So these cancel out. Okay, so we don't care about these 2. Those are basically getting ignored, but we still need to know this. Any ideas on how to find that area? I'll give you a second. Perfect. So we're going to find the area of the rectangle, and then we're going to minus the circle out of it, and whatever's left over would be like kind of like the crust, if you will. Okay? So for this chunk right here, we're going to do the rectangle minus the half circle. Okay? So let's do the rectangle first. What are the dimensions of the rectangle? How far across? 2. And how tall? So 2 times 1 is 2. Okay, then for the half circle, it'll be half pi r squared. What's my r, though? 1. Because if all the way across the circle is 2, the radius is only 1. So I'll do a half pi r squared. Okay, but 1 squared is 1. Half of pi would just be pi halves. So this area here is going to be 2 minus pi halves. Okay, for that kind of weird little shape. And then what do I do with the trapezoid from -3 to 0 and then the weird little shape? Just add them up. Good. So in my chart, I'm going to do 4.5 plus 2 minus pi halves. Okay, and then again, if you're not remembering, the triangles at the end canceled out. That's why I never found them, because they were the same. Okay, and then can I put any of that together? Yeah, 4.5 and 2 make 6.5. And then this is where you would say, okay, I only need to know which one's the smallest, right? So out of 0, a negative number, and a positive number, which one's the smallest? Okay, the negative. Now, if you're not sure about this, pi is like 3. So 3 divided by 2 is 1.5. What's 6.5 take away 1.5? About 5. We don't know exactly what it is, but we know it's not negative enough to be smaller than -1. Yeah, but the triangles cancel out. Because you have the one on top and the one on bottom match each other. So that's why we didn't find those. Because they just cancel. Okay? So I would say my absolute min is this right here. Then remember, for your answer, you would write the absolute min is -1. It occurs at x equals -4. Okay, but remember, the minimum is how low the y value is, and then it occurs at the x value. Okay? All right, next one. Find the values of x where points of inflection occur. Okay, so points of inflection occur when g double prime changes sign. What is g double prime the same as? F prime, which is the... So look at your graph. How many times does the slope change sign? I count 3. Look and see if you find out 3. Okay, where's the first one? Okay, it goes from uphill to downhill. Then where does it change again? Well, now this is downhill to downhill. Does that count? No, it has to change sign. So this is downhill, and then this is still downhill. Now, is there a cusp there? Sure, but is there a sign change for slope? No. This is your next one, the bottom. Very good. Because what happens? It goes downhill, downhill, uphill. And then where's my last one? At 2. So you have these 3 spots here where your POIs occur. Okay? So let's write that out, and then you guys will be able to hopefully do the next FRQ by yourself. Okay, so x equals, first one was -3, next one was 1, next one was 2. And then we would say these are POIs because G double prime, which is really F prime, the slope of F changes sign. Okay, and then remember that you don't care what direction it changes sign. As long as it changes sign, you're going to have a POI. So it doesn't matter if it goes minus to plus or plus to minus. You don't have to worry about that. Okay, the last part of the question we have not done before. This is the first time I think you're seeing it. Okay, so take a look at part F. For me to find capital F of 0, does that have anything to do with G? No. So the first thing I'm going to put here is that G is irrelevant for part F. Okay, nobody cares about G. I needed it for every other question until I got here. I'm only looking at F. What do I have in my graph? I have little f. What do I want in part here? Big F. What's the relationship from little f to big F? Antiderivative. So I know I need to integrate little f. Okay, what y value am I looking for capital F at? 0. And what x value did they give me capital F at? So I'm going to make my integral from -5 to 0. Here's why. What's the antiderivative of little f from -5 to 0? This is one of your rules. Capital F at 0 minus capital F at -5. Remember, that's the fundamental theorem of calculus, right? So if I want f of 0, and they're telling me f of -5, they're telling me that it's 7, then that means that the integral from -5 to 0 is f of 0 minus 7. Well, then if I want to solve to get this by itself, what do I do with the -7? I just add it across to the other side, and then f of 0 will be by itself. So I'll have f of 0 equals 7 plus the integral -5 to 0 of f of x dx. Now, can I work out that integral? Yeah, look at your graph. From -5 to 0, how much area do I accumulate? Only 4.5, because what happens with the pink triangle from -5 to 3? Those cancel, and then I just end up with the 4.5. So it'd be 7 plus 4.5, which is 11.5. Does that make sense? Okay, so from now on, I'm going to call that version B of the fundamental theorem. So flip back over to the front of your notes, and we're going to write it on the front. Okay? So flip back over to the front. So your fundamental theorem is this. Your second fundamental theorem, okay, my second fundamental theorem is going to be f of b equals f of a plus the integral a to b of f of x dx. Okay, but technically, okay, it's still this exact same theorem. What's the only difference? I took my f of a that was minus, and I just brought it across and added it to the integral. So these are the same. The only thing that changed is I'm taking the minus f of a off the back, and I'm adding it in front of the integral, so f of b can be by itself. So that's going to be called version B. And it'll come up in the next question, but I'll help you with that part. Okay? So what I want you to do is I'm going to bring you a little candy, and I want you to try the next free response question. You should be able to do all of it, and then tomorrow we'll add chain rule to this. Okay? You're gonna love it. You're gonna love it. Okay? Turning it. Good. So you're doing this one. Oh, dang. This isn't the kind of question I want. Never mind. Do this one. The reason why is the other one has random, like, products and quotient rule in it. Okay, do this one right here. Oh, this one has a trick in it, too. Okay, what do you notice is different about this one? X is at the bottom, so when you plug your number in, are you going to put it in the top of the integral? You're going to put it in the bottom of the integral. Okay, give it a shot. Okay, and then I'll help you. You can do it. It depends if it comes out backwards or not. So, like, for example, when I plug in G of 2, 2 is going on the bottom, 3 is on the top, then is it really backwards? You see what I'm saying? Now, when you take the derivative, you're going to lots of Tootsie Rolls up for grabs, people. Why do you not like Tootsie Rolls? Oh, the munchie. Maybe are you sad now? Yeah. Are you playing in? Oh my God. 3 to like see 1. How did you figure out? Okay. Can I give it to you? Yes, I have it on my clipboard, but I've had to cover 9 million classes. Covered for Mr. C today. Yeah, we get $20. So it's like not enough to make it worth it, but well, it depends. We get $20 if the teacher is out with itself. But if they're doing something for school on campus, then we're covering it basically. Huh? Can't. That's actually not a requirement. I can't do CPO. I mean, I got certified in like middle school, but I don't feel confident I could keep anyone alive. I just probably panic and then have a heart attack myself. You can have, if you pick a Tootsie Roll, because no one picks them here. Look. Share with a friend. Tootsie Rolls? See, no, you guys try to take my good candy. What are you talking about? You took a Tootsie Roll? The skinny or the fat ones?
The skinny blue or green.
Oh, see, no, those don't count as the candy I'm trying to get rid of. I have like 90% regular Tootsie Rolls. That's gonna be my new reward when you do something. No more burger puffs, just Tootsie Rolls. Okay, let's see how you did, even though the integral's backwards. Okay, so when I want g of 2, I'm plugging it in for x. So g of 2 is the integral from 2 to 3 of f of t dt. Did it come out backwards? No. 2 to 3 is here. So my area there is a triangle. So it'll be 1/2, my base is 1, my height is 2. 1/2, 1 times 2 is 1. Positive or negative? Why is it -1? Because the area is where? Below. Now, one more thing here. Technically, and this is where it kind of depends how mean your grader comes out to be when you take the AP test. But is this equal to -1? So I need to make sure that when I apply the negative that I do it before that as well. Okay, you don't want to have stuff with equals between them that aren't really equal.
What if you just write the answer down?
That would be fine, as long as you don't put it positive and then set it equal to -1. Okay, next.
It was -2 because it. Yeah.
Oh, you're talking about like the height. That's fine. What'd you say? You might have to do that your free time. Okay, look at the next one. Now I want G prime. Okay, but what did we say about if X is on the bottom? If X is on the bottom, can I use my rule? No, so I have to flip the order to use my rule, which means I have to apply a what? A negative. So look, this is the same as 3 to x of negative f of t dt. And then I can plug the x in, so it's negative f of x. Yeah? Okay? And then from there, what is g double prime of x? Negative f prime of x. Okay, so when they give me the integral backwards and I take the derivative, it puts a negative into it, which carries down to the second derivative as well. So now when I want g prime of 2, I really want negative f of 2. Did they trick you or did you get it right? Okay, so, but then f of 2 comes out to be 0, so actually you just get 0 either way. Okay, but then g double prime of 2 is going to be negative f prime of 2. So what is the slope of the graph at 2? Well, what's the slope of this line? Negative 2, but then if I apply the other negative, it's actually positive 2. They'd give you separate points. Okay, all right, part B, I want g of -1. That's all I need is just get some points where you can, people, okay? -1, remember we're putting that as the bottom to 3. Okay, then -1 is going to start here. And I'm going to shade all the way until 3. What's going to happen? These two bottom ones are going to cancel with these two, and what's the integral? 0. Everything cancels out, basically. Okay, then I want g prime of -1. Well, that's negative f of -1. Remember the negative, because when I took the derivative, I had to reverse the order. So what is f of -1? -2, then -2 is really positive 2. Next, I want g double prime at -1. G double prime of -1 is going to be the slope at -1, which is what? dne, because why? Because f has that is a corner. If you accidentally said cusp, I don't think that they'd care, but you just never know how picky they're going to be. Okay?
Bro, imagine being so picky on a high school game.
But you're taking a college credit class.
Yeah, but we're high school.
Yes, but... Okay, now we'll come back to part C. Let's go to part D. Okay, I want critical numbers. Where are the critical numbers going to be on the graph? On the x-axis, so I'll have 2 of them. Okay, but question. Okay, listen. Does 0 count as a min or a max? We'll see who's thinking. No, it counts as one of them.
It's going from negative to positive.
But what is g prime?
Negative.
It's a max. It's trying to trick you. Okay, because think about if... Okay, you have to think in steps. So listen, on this side, f is negative. Well, then what's negative f of x? Positive. And on this side, when f is positive, what is g prime really? Negative, because it's always the opposite. Okay, so normally this would be a min, but because of the negative on the f of x, it actually makes it a max. Okay, so let's write that out. Okay, so my critical numbers are 0 and 2. Normally 0 would be a minimum, but we're going to say it's a relative maximum. Because g prime of x, which is really negative f of x, changes from positive to negative. And remember, why is it changing backwards? Because of this negative. That affects everything. Okay, what would we say then that 2 is? Okay, relative minimum, because g prime of x, which is really negative f of x, changes from negative to positive. Okay? Next, I want the absolute minimum. Then what do? Make a what?
Candidate's chart.
Candidate's chart. Now, I put the wrong endpoints on this. It should be negative 4 till 3. So negative 4 goes here, 3 goes here. And then if I want a minimum, what's the only critical number that I care about? Is it the 0 or the 2? I care about the 2. And did I already find g of 2 in part A? What was g of 2? Negative 1. So I'm not going to go back and find that. I already know what that is from part A. Okay, but I need to know g of negative 4 and g of 3. Let's do g of negative 4 first. Negative 4 goes in at the bottom of the integral. And then when I do g of 3, it'll be the integral 3 to 3. Bless you. What do you notice about which integral is going to be super easy? 3 to 3 is just going to come out to be 0. Because I'm starting and stopping at the same point, so I don't even really have to do math there, right? I just recognize they're the same, that one's 0. Okay, now negative 4 to 3 is going to be all my areas, so let's look at our graph. Okay, if I start at negative 4, what is the only shape I'm going to actually have to find the area of? To here, because what happens with these two? And then these cancel. So basically, I only care about the trapezoid. So it's going to be 1/2. How long is this base here? 2. How long is this base here? 3. So it'd be 2 plus 3. And then how wide is it? 3. Because remember, I can only count from 1 to 4 for my base. So 2 plus 3 is 5. 5 times 3 is 15. Half of that would be 7.5. It is negative because why? Because the area is below the x-axis, yeah? So out of my 3 values, which one is the smallest? Good. So the absolute min is negative 7.5. It occurs at x equals negative 4. Okay, then where are my points of inflection? There's only one. At 1, very good, right here. Because what happens to the slope before that? It's uphill, then it changes to uphill, which doesn't count, then it changes to downhill. So 1 would be my only point of inflection. Because, now, if I put this is going to be wrong. Why is that wrong?
You have to say the slope.
Okay, actually 2 things are wrong on accident. The first one I meant to do is what you said, Hannah. Okay, what is g double prime equal to? Negative f prime. And then what's the other thing I have to say, Callie? Okay, the slope of f. Okay, because remember, you have to connect your explanation to the picture they gave you. So you're telling them, I was really looking at the slope. Now, technically, what am I looking at? The opposite of the slope. But that doesn't matter as long as it changes sign. That's good enough. Okay? Great. Okay, now, let's go back to part C. The part that we skipped. Okay, I want G to be increasing and concave up. Okay, let's break that down. If G is increasing, then G prime needs to be positive, right? If G is increasing, then G prime needs to be positive. Then what does F have to be? Negative, because why? Because G prime is negative F, and so I need F to be negative to cancel out the negative. Does that make sense? So what I would think about in your head is you're really just looking for the opposite. If I want G prime to be positive, I need F to be negative. Where is F negative? Okay, when it's below the x-axis. Okay, and what else do I need the graph to be? Concave up. Okay, so if I want G to be concave up, then G double prime needs to be positive. If G double prime is going to be positive, what do I need the slope of F to be? Okay, and I need a negative slope. So look at your graph. When am I both below the x-axis and I have a negative slope? I don't only want one, I need both. 2 to 3. And then I would say because G prime of x, which is really negative f of x, is greater than 0, and G double prime of x, which is really negative f prime of x, is greater than 0, and then I would put the slope of f. Okay, but the only tricky thing is you have to remember that those negatives in the front mean you're really looking for like the opposite of what you would think you would be looking for. Does that make sense? They've only put a question like that on the AP test maybe once or twice. Usually they do it regular without it being backwards. Okay? Now, the last question that I want to just give you to think about is what if they told you to find, let's say, f of 3, and you were given f of 0 is 10. Let's just pretend that they gave you that. Then what you would do is you would set up the version B. Okay, the integral from 0 to 3 of little f is capital F of 3 minus capital F of 0. And then what did they tell me f of 0 is? 10, so I would take my 10, I would add it to the other side. So f of 3 would be f of 0 plus the integral of 0 to 3 of f of x. And then f of 0 we said is a 10, and then that you would do by area. Now, 0 to 3, if I were to do this integral, 2 of the triangles will cancel out, but I'll have 1 left over on top. That's 1. So it would come out to be 11. Okay? And that is your version B. We'll look at that more tomorrow. Okay? Yeah. You all got the top? Good. There?